Okay. Okay, guys. So I'm gonna continue what I started last time. So yeah. So here I want to talk about network topology. So I want to explain what I mean by topology and so on. So the main idea here, we have a number of computers. We want to connect them together, and that's what we call network. So how we can connect them together so that any computer can send data to any other computer, okay? So there are different ways. One way we call it bus topology. So as you see here, this is a common bus. Common bus means if any computer here, if any computer sent a message here, anyone can get it, right? Because it's a common bus, okay? So, however, every message should have address so that every computer can access the bus, everybody can get the message. However, everyone is gonna look at the address. If this address is not mine, so I'm not gonna get the message. Okay. So this is the main idea. This is how it works. So when a node or a computer transmit a signal, everyone else can get the same signal. However, a node ignores the message or the signal that's not addressed to it. Okay. Another issue here, signals may collide with each other. What it means? It means it may happen that two computers or more can transmit at the same time. That's what we call collide. You got what I'm saying? So this one is going to send, this one is going to send at the same time. So what's going to happen? There will be like some kind like a noisy signal on the bus. So no one can use this signal. So actually, this is a very bad, it's lose situation. Very bad situation. Lose. Why lose? Because everybody lost. We lost this bus. No one used it. Okay. So we need some way to coordinate the use of the bus. Okay. So you should know what is the term of collide. They collide. Okay. By the way, the same thing happens in the air, in the Wi-Fi. Okay. So if several wireless devices, all of us are in the same area, right? So if you transmit and I transmit at the same time, we can also collide. That's why there are some mechanisms, there are techniques, so that we can coordinate the transmissions, okay? So here, this is one of the problems. So we need to arbitrate here, okay? Who's gonna get the bus, okay? For sure, again, I'm going to teach you different topologies. Every topology is good in some things, and also it's bad in other things, and so on. Okay. So here, broadcasting messages. Okay, it's a good for sure for broadcasting, because I'm going to send the message only one time, right? So only one time, and everybody can access it. Okay. Bus failure may bring the whole network down. For sure, this is a bad thing. If there is a failure in the bus, so the whole network can be down. Okay. Failure of a node causes no network failure. Okay, so if one computer here fails, the whole network is still okay, right? Because in some other topologies, this is not the case. In some other topologies, if one computer fails, the whole network fails. Okay. Anyway, the other topology, the use of what we call slave and master. Okay. So we can have here a computer, he's gonna organize everything, okay? So if this guy wanna talk to this guy, so I have to send to the master is gonna send it here. So everything should be done using the master here, okay? This is what we call star topology, for sure. So each node is linked to one central unit. All messages are sent from one client to another through central unit. So everything should be. Central unit here, what we mean by central unit is the master, okay? If one slave computer fails, no other clients are affected. So if this one fails, this is not going to affect any in the network or anyone else. But if the master fails, the whole network is going to fail. Okay. For sure, it's easy to arbitrate. However, because the master is going to decide everything. However, it's not scalable for sure. If you have too many computers, the master here is going to be like a bottleneck. Okay. Another thing here, the ring, the idea of the ring, as we see, you can create like a ring here, and then so here, so for example, if this guy here A want to talk to B, so you can send your message this way to this one, this one, this way. Usually it's one way, okay? So your message can go this way, okay? But also, who should use the ring? There are different ideas, but a very simple idea is using what we call token. So the idea here, there is a token, okay? Token means like a permission for transmission, okay? If I receive this token, okay, so now means I have the right to transmit, okay? If I receive the token and I have no message to transmit, so I'm gonna pass the token to next one. If I don't have any message, I'm gonna pass to next one. If I don't have any message, I'm gonna pass to next one, and so on, okay? Yeah. So as I said here, a message sent out from one node is passed along to each node in between. So it has to go this way in between until it reaches to. So if the ring can be broken if any cable or computer is damaged or broken. For sure, this is a bad thing. This is a disadvantage. So if the computer fail, the ring is gonna fail. Okay. The last one here, another topology, we call it the mesh topology. Okay. In mesh topology, as you see here, guys, every computer is connected with each other computer, as you see here, okay, using a link, okay. So here, this one has a link here this way, okay. The good thing here, we don't have the collision problem because we don't use anything shared, okay. However, for sure, this idea is very bad, especially for scalability, because you have to use a lot of links, you have a lot of computers. Any questions? Okay. So the next thing I want to talk about is we have two types of communication. You may hear these two types of communication all the time. One is called peer-to-peer, or the other one is client and server communication. Client and server. Okay. So I'm going to explain what is the definition, what is the difference. So just a definition. So in case of client and server, okay, usually you have a server, like for example, CNN server or a certain website server. So you have a server, and you have many users that access this server. So usually that's how it is. You have a certain server, whatever the server is, and you have many users who are accessing this server. Okay, this server can be email, or can be a website, or can be email, or whatever. Okay, so this is completely different from peer-to-peer communication. So in case of client and server communication, so number one, who's gonna start the communication? The client. So usually the communication starts from here. So for example, if I wanna see the website of CNN, so I have to send a request this way, and then so I have to start from here. You send a request, and then after you send a request, you get a reply back. Okay. So the client initiates the communication by sending a request, and the server is gonna wait response to this request. Okay. Same thing for your email. If you send your email request for your email, you get your email back. A server receives a client's request and responds with replies satisfying the request. Okay. Typically in this case, okay, there is a big difference between the client and the servers. Server has to be very powerful because the server has to serve many users. Okay. So typically a client has lower computer capability, but the server is dedicated or always on computer. Okay, it should have a large capability because it can serve too many users. Okay. Servers do most of the processing. Okay. Client and server are dedicated to their respective tasks, and those rules never reverse it. So the rules are not reversed, so the client cannot be server, so they cannot exchange their rules. As I said, we have different types of server. We can have email server, we can have web server, we can, and so on, okay? Like HTTP is a protocol we use for websites, okay? The second communication is peer-to-peer, okay? And you can steal from the word peer. Peer means or equal peer, right? So here, peer-to-peer, here, it's like one computer is communicating with other computer. So this kind of communication is completely different from this one, because now, in several things. Number one, anyone can, so now we have two computers, they almost have the same power, right? So it doesn't need that one of them is much more power than the other one, so they almost the same. Each peer has equal responsibilities, okay? It's different from this one where most of the work is done here. Anyone can start the communication, okay? And for example, we use it like in Skype and also in voice over IP, in general, BitTorrent and other applications, okay? Anyway, so in this part, I just want to repeat something here. As I told you in chapter 1, I'm just making some definition. I'm teaching some concepts about network. I'm not going to teach too much details because chapter 1 by itself can be a course about networking, right? But the purpose of this course is to focus on security, network security. Chapter 2, I'm going to teach some security and crypto stuff. After that, we're going to do some advanced topics. And some of these tools are really very interesting, like blockchain, okay, and other these technologies. Okay. So anyway, so here I want to make some definition. So we have some network nodes. You should understand what is the difference between repeater, switch, gateway, router. Okay, so let's make these definitions. Number one, repeater. Okay, so what repeater is? I'm going to tell you very simple. If you send the signal here, for example, I send the signal this way, you know, as we go far from the source of this signal, you know the signal will be weaker, right? So it will be very weak, noisy and weaker, right? So here what's going to happen, this repeater is going to do like an amplifier. So it's going to reshape and amplify the signal. So here the signal is going to be weak, very weak signal, something like that. After here, this one is going to repeat it or is going to amplify it, okay? So that we can, it's like you can see it like we extended the bus. So if you have a bus, you should have a limit on the length of this bus, because once you send the signal will be too weak here, too weak to listen or to receive. Okay? So by putting repeater here, we can extend the bus. Okay? So repeater is a very simple device, very simple. It doesn't have any intelligence or doesn't do anything. Just it works at the physical layer. You know, as I'm going to explain also later, we have the layers, the network layers, right? So the first layer is just physical layer. Okay, I'm going to explain later what are these layers and so on. But this one works as a physical layer. It just amplify or reconstruct the signal. That's okay. Second one, which is switches. They are widely used switches. Okay, the switches they are used as a second layer or link layer device. Okay, this one has some kind of intelligence because this one has it should receive a frame and has to do some processing to frame to know where it has to send this frame. Okay, for example, here I have a switch, for example, this way. Okay, again, every computer here, because again I'm talking about the second layer, which is at the sometimes we call it MAC layer. Okay, sorry, MAC layer. So anyway, so every computer here has address, a unique address in this network, right? So this is a small network, like for example, like TTU here can be a network, right? So this is a network. This network has a number of computers, okay? Every computer should have a unique identifier. We call it MAC address, okay? So You know, every computer or you have two identifiers. You have MAC and you have IP. So I'm gonna explain what is the difference between them clearly. But here, because this is just one network, so here MAC, everyone here has a MAC address, and address, unique address, we call it a MAC. Okay, and this one is used only in the second layer. IP is used in the third layer. Okay, so here we don't need the third layer here because this is one network, so there is no third layer. Okay, the third layer is used and as I'm going to explain later, this is a network, this is a network, this is a network, and then this network connected using routers. So here you have a router here, you have a router here. Okay, you have a router here. In this case, we need the IP, okay? Because MAC is identifier inside this network. So inside this network, the identifier is a MAC, okay? IP is a global identifier. As I'm going to explain later, the IP is a global identifier, okay? It should not be repeated globally. And IP somehow is different from MAC, as I'm going to explain later, because IP is related to the location. There should be location component to IP. MAC we call it flat, but IP is hierarchy. I'm gonna why it is hierarchy. But you know, if I have the IP address, I can know the your location, right? Because every location has a different IP. I'm gonna tell you why they made it this way, okay? But the MAC is flat. So there is no hierarchy, just identifier, okay? So anyway, so what I'm saying here, I want to talk about the switch, okay? So here TTU should have a switch or more than one switch. So how can we connect all these computers together, okay? For example, here, I got a message from here, this way, for example, and when I get this message, I'm gonna look at the MAC address. If I find the MAC address is this computer, so I'm gonna forward it from this way. Or if it is in this computer, so I'm gonna forward it this way, and so on. So it should have a table. This table should have all the MAC addresses connected to number 3. So this switch has three inputs or outputs, 1, 2, 3, right? So it should know the MAC addresses connected to 3. Should know the MAC address is connected to 2, MAC address is connected to 1, so that when I get a message, I have to know where it has to go. There should be like a routing table, okay? And there should be a protocol for that. There should be a protocol to let the switch know what devices are connected here. So okay, so from time to time, every device has to broadcast a message with its MAC address. Anyway. So that's what the switch is doing, okay? So the switch is used in the second layer inside one network. This is one network, as I said. IP is used if you want to connect multiple networks together. So the switch should only look at the MAC. It doesn't care about the IP for sure. It's going to look at the MAC, and then all what it has a routing table. It's going to, if the MAC is going to look MAC, and then this is where it has to go. For example, if this is this MAC, it has to go to 3. This MAC value, it has to go to 2, and so on. So all what it's gonna, after it receives a message, it's gonna look at the MAC, and then it's gonna send this way or that way, and so on. Okay? Okay, the second device I want to talk about, which is a router, right? Big difference between the router and the switch. There are some similarity and there are some differences, right? So here, a switch is used in the second layer, right? The router is used in the third layer, okay? Router is running IP protocol is running here. Here we use MAC, okay? So the idea of the router is, it's very close to the switch. So if here, this is one network, right? So usually we have a router here, okay? And then we have here, for example, a switch. and then we have a bunch of computers. Okay, so if this computer sends a message, okay, this switch is gonna look at the MAC address. If the MAC address is inside here, okay, it's gonna send it to the MAC address directly because we don't need the third layer. If one computer wanna talk to another computer in the same network, we don't need the third layer, only two layers. Okay. However, if you wanna talk to someone in a different network, okay, so you have to send it to the router. The router has to send it to another router and so on. Okay, so anyway, I will give you more details later. But for now, I can show quickly a figure here. Yeah, something you will see something like that. Okay, so for example, so here anyway, I'm gonna explain it later. But this is one network. Okay, so if the MAC address is not here, so I'm gonna send it to the router. Okay, the router is gonna use the IP, and then it using the IP, it should know should I send it this way or this way, maybe this way. Okay, based on the IP, right? So it has something similar to the switch. Like it should have a table, a routing table. In this routing table, based on the IP, should I send this way or that way? However, router again is more complicated than the switch because the switch you only take care of just a number of computers locally, right? So usually even the routing table may be simple in case of the switch, but in case of the router is more complicated. Okay. But again, the very simple thing is, if you wanna, the similarity is both of them are device. This device should receive a signal, receive a message, and then it has to decide should I send message this way or that way. Both of them are doing that. Okay. However, the difference is that in case of the switch, okay, it's used if you want in the same network, right? If one device want to communicate in the same network, okay. Router is used if you want to communicate with someone in a different network, okay, and for sure maybe different country, maybe different area. Okay. Anyway, so let me read what I wrote here. So here, this is a network layer device. Okay. Again, when I say network layer, that means this is one device in a network want to communicate with another device in another network. Okay. That sends packets or messages in one of many directions to get them to their destination. For sure, this one is more sophisticated addressing than switches. Sometimes it can determine preferred paths. Sometimes, if you have different paths, you can select some paths. This one is store and update a routing table. Again, this routing table should tell if the destination IP has this value, so it has to go from output number 2 or output number 1 and so on. So routing table. Okay. So here, both of them are store and forward devices. The switches are link layer devices. Okay. Routers maintain routing tables and implement routing algorithms. The switches maintain a switch table, which is a very simple table, as I said before. Okay. That's what I said. That's exactly what I said here, guys. This is maybe one network, as you see here. This network, okay, it has one router, okay. So if you wanna talk to any other device outside this network, okay, and we have a switch here. So if you want to communicate locally, so it's not going to go to the router. So it's not going to even go to the router. If this guy want to talk to this guy, so the communication will be through this switch. It's not going to even go to the router at all. Okay. So This is how the network, this can be like a TTU network, for example. You got what I'm saying? You have a number of servers, number of computers are connected together. But as I'm gonna explain later, if in case of the internet, I'm gonna tell you what is the internet. The internet is a network of networks. Okay, so every here, this is one network, and then we're gonna connect them together using here. This one has a router, this one has a router here, and this one has a router, and so on. Okay, network of networks. Okay, you know. Another device, we call it gateway. So the gateway is used in case if you want to connect two networks. However, these two networks use different protocols. So this one be like a translator. Okay. So for example, the frame, the format of the frame, the protocol is different. So here, when I receive, this is like a translator. Like, for example, if I have a certain message using this protocol, so I have to translate it to another, to the protocol used here, and also the same thing the other way, right? It's like two people speaking different language, and I would have to put a translator in the middle. That's exactly what happened here. This network using a certain protocol, so it defines the message in a certain way. The format of the message is different, and we have to look here like a translator to change it, the format of the message from here to here. Okay. 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 The second part here, I want to talk about internet. Okay. So as you see here, the internet, I can say it is two parts, as you see here. One part we call it the access network, and the other part, as you see here, this part here, we call it the backbone of the internet, backbone. Okay. So first, the internet, this is a very simple definition to the internet. Okay. This one, a network of millions of connected devices. Okay. Running for sure different applications. Okay. So it has hierarchy. I'm going to tell you what I mean by hierarchy exactly, because the IP itself is not flat. What you mean by flat? I mean it's not a random number, because if it is a route, if the IP address is a random number, routing is going to be too difficult. You got what I'm saying? It's a very good example to understand what I mean by hierarchy is exactly like when you use your home address, how you make your address. It's hierarchy. How it is hierarchy? For example, you have USA, right? This is one level. Inside USA, you have Tennessee. This is second level hierarchy, right? So in the beginning, you have different countries: USA, Canada, India, whatever. So you have many countries. Okay. Inside this country, another level, Tennessee, right? Inside Tennessee, Cookville. So we already have different different cities. Inside Cookville, a certain street. Inside this street, a certain number. This is the same thing for IP, as I'm going to explain later. So for IP, you have one part to tell you, okay, so all this area should have the same part, common. It's exactly like everyone in the US should have this part, USA. Everyone in Tennessee, okay, should have this part, which is Tennessee. Every part in Cookville. So this is the same thing, but for IP. Okay, it's a part of the IP, right? So, and as you will see later, here I'm explaining what I mean by the word hierarchy, okay? And also, they made it this way so that we can make routing efficient, right? If we don't do it this way and we make it randomly, okay, it's going to be too difficult for the routers, because the routing table of the router should have all the IPs of all the people. Okay, so the routing table is going to be huge, right? As we'll see later. But the idea is that, for example, if this router has, for example, 3-4 outlets, for example. So here, I don't want to, I'm not going to store billions or thousands of addresses and say all these addresses has to go to in output number 1. I'm not going to do, okay? If it is flat, I have to do that. Like in Mac. in MAC addresses, because they are flat, if I use MAC addresses instead of IP, I have to do it this way, right? However, all that I'm gonna do, I'm gonna say, just look at this part. If this one is going to Tennessee, something like that, okay? So if you look at this part, if this part is 0, 1, 0, 1, 0, 1, whatever, certain value, so it has to go to 1. So instead of storing too many, no, anything that has Tennessee has to go this way. What I'm saying? So that's why we can do routing using, if we have billions of devices, right? This is completely different from the switch, because the switch usually used it for a small network, right? So it's not a problem to store all the MAC addresses. It's not a problem, right? But if you store all the IPs, it's going to be for sure impossible. Okay, so that's what I'm saying here, guys. So you can see the internet, like you have here backbone, what we call a backbone, okay, and then we can here we have what we call access network, right? So for example, here access network, like for example, it can be TTU, right? So you can access the network from TTU. So who's gonna connect you to the backbone? Who's gonna connect you? This is what we call access network, right? Or it can be home network. It can be home network that connect you to the backbone, or it can be cellular network, as you see here, right? So you connect it to the tower, and then the tower is gonna connect you to the backbone, and so on. Okay. Same thing here. You connect it to the router here. The router, we call it a router. Okay, but this is different from what I mean by this router here. Okay. This one is gonna connect to all. Okay. So you connect here to the Wi-Fi. The Wi-Fi is going to connect you to the TTU network, and then you can connect this router here is going to connect you to the backbone. So we have two parts. That's what I want to say. We have two parts. One part is the access network, the network that is going to connect you to the backbone, and then we have the big backbone, or sometimes we call it the core network. Okay. This core network is actually the internet service provider. It's just a bunch of routers connected together, as you see. Anyway, so for access networks, for sure there are a lot of different ways to connect you to the internet using the access network. For sure, some of these technology are very old, and I don't think this technology are used anymore. Okay, so very old technology, they are not used anymore, but we used to use it in the past. Okay. As access network. So here I'm focusing on some of new technology, like for example, in case of residential access, we can use fiber optics, because the great advantage of fiber optics, is a rate. It can transmit a lot of data in a very short time. Okay, it's really fiber meter resolution. The amount of data you can transmit comparing to copper or any other metal or something like that. Okay, so yeah, fiber, you can transmit a lot of data. Okay, so you can connect here some fiber. I think most of the places now is using fiber, optical fiber. Okay, the fiber is. I think I have a picture here for a fiber. Fiber is light, right? Light. You took your. Do I have a picture? Yeah, I think I do. Let me see. No, I don't. Yeah, here. Yeah, something like that. It's a light. So you have to convert the electrical signal to light, and then you have to transmit the light. Okay, over fiber. Fiber is some kind of plastic, glass, something like that. Okay, that allows the light to go through it. Okay? And then, as the other side, you have to convert back is the light to electrical signal again. Okay? Under the ocean, under the under many seas, there are cables, big cables, some fiber cables that will connect countries together, that can connect continent together, fiber together. I'm not sure. Sometimes I'm not sure if it happened recently. There was an incident. I'm not sure if you heard about it or not. Something happened in one fiber, and it affected many countries. I think India was one of these countries, and other countries affected in some countries because there is a damage in fiber or something like that that connect countries together. Okay, It's a very good technology for sure, because the transmission rate can be very high. Anyway. So this is one way we can use fibers, as I said, this way, okay. The other way is Ethernet. I think we use Ethernet. Ethernet is a cable. You know the cable we use here. I didn't see this. You know, the cables that connect your computer. This is the Ethernet. Okay. So for example, here as you see, you have here, for example, Ethernet switch. You can connect your computer to the Ethernet, and then the Ethernet is connected to router, and then the router can go to the internet service provider this way. Okay. The Ethernet can go up to 10 megabit per second, 1 gigabit per second, and so. Okay. It's a cable, the cable we use. For sure, most of the time we use Wi-Fi. Is that okay? We use Wi-Fi to connect to, as you see here, we have like a base station. We call it a router, but it's like a router. We connect it to the base station, and then the base station is going to connect to your router. Router is going to connect it to the internet service provider, and so. Okay. Anyway, so this is the access network. So all the access network has to do it has to connect your computer to the backbone of the internet. Okay. The backbone here of the internet is, or what should happen is that it's infrastructure interconnected different sub-network, okay, like a mesh of interconnected routers. This is the core, okay. So what I want to explain now, now I want to focus on the backbone here, give you some idea about the backbone here, okay. How is data transferred through the backbone, yeah, okay. So that means what I want to say, if you receive a message, receive a message from here, okay, so I have to decide how this message has to go, so that at the end it has to come this way or that way, okay. How this is done? How, if you receive a message, if I want to connect this computer to this computer, how something like that can be done, okay. So I'm gonna talk about two technologies. One of them, I think now it's not used anymore, or yeah, so I think it's still used in the home phones, okay. But it started, most of the people now are moving to the second one, packet switching. So here I want to talk how you switch how you connect this device to this device. So I'm going to talk about two different technologies. The first one, we call it circuit switching. So let's see what I mean by circuit switching. Circuit switching we used it during the telephone network, okay. I'm going to tell you and how it works. Also, how packet switching works, and how the differences between them. Okay, this is not bad all the time, by the way. So when I explain it to you, we think it's bad all the time. No, it has some advantages, as I'm going to explain. Okay, and also you should understand. So circuit switching is mainly used for voice communication. So it was designed for voice communication, so it's okay for voice communication. So it's not good for data communication. That's why this one is good for data. So what is the difference? That's one basic. Okay, explain. So when they did the very beginning, before they invented internet or all these things, you know, we used to have phones, right? Home phones, right? In home phones, usually it's designed to transmit voice, not emails, not files, voice, right? So when they designed the circuit switch, they designed it to transmit voice data, which is good, right? So they designed for that. However, if we want to use it for data communication, it's not going to be good at all. So let's see this one first. You remember when you have a phone like this one and you dial a number? Actually, when you dial a number, you know what you are doing? You have a number of switches this way, okay? And then when you dial a number, we are gonna connect you with another phone number, a phone here, okay, another phone, okay? So what happens is that we actually create a physical wire. So these switches are gonna make like a wire this way, okay? So if this is person A and this is person B, so actually there is a wire between these two people, right? Dedicated, we call it dedicated. What do you mean by the word dedicated? I mean, this wire is used between A and B, right? Nobody else can use this wire. For example, this connection here, this connection is not shared. It's not shared. It's just between A and B, right? So when I hang up, okay. So actually, this now is free. You can use it for someone else. But while you are talking, okay, this is just between us. No one else can use it, right? You can see this is good, and also you can see bad. Okay, I'm going to tell you why or whatever. Okay, but this is how it is. Okay, so when you dial a number, you actually connect these switches, or it's going to connect like something like a wire. Okay, this way. So you establish actually end-to-end circuit. Okay, or you actually allocate resources. What is the meaning of the word allocate resources? This wire is resources, right? So it's a bandwidth, it's a resources. So you already, I give you this resource, it's for you, right? It's not shared with someone else, it's for you. You get what I'm saying? So I allocate this resource for you. You will understand what I'm saying better when I talk about the internet, because the internet, I'm not going to give you anything. Just a transmit. If I can deliver it, I will deliver it. If I can't, I'm not going to deliver it. Completely different concept, right? That's why here you have to dial a number, and then after you dial a number, you actually is going to program these switches. So you are going to set these switches to connect this wire. So you already have allocated bandwidth, allocated resource for you. Okay, it's guaranteed. Something guaranteed. In the internet, nothing is guaranteed. Just transmit. If I can, I will do it. If I can, I'm not going to do it. Okay. So here, what you should understand here that this was designed for voice communication. Okay. So here, number one, you need to establish end-to-end network. This is number one. This is after you dial the number, and then you transmit the data, which is your voice when you talk to someone else. And then you have to terminate. So once you hang up, you actually deallocate the dedicated resources. So this wire is not yours anymore. So I can give it to another person. So another person can take this wire. Sorry, can take this connection somehow. Okay, and so on. Okay, is established between the two ends. Okay, so this is what we call circuit switching. Okay, in packet switching, which is used in the internet, the idea is completely different. Okay, number one, I'm not going to allocate anything for you. You have nothing. Okay, all what you have to do, if you want to send some data, just send it to the network. Okay, and the network is going to do what I promise you. I will do my best to deliver. If I can deliver, I will do. If I can't, I'm sorry. That's it. So nothing is guaranteed. You got what I'm saying? That's why I explained last time about the congestion. If there is a congestion, so if you have a router here, this router is receiving too much data, so the arrival rate is bigger than the transmission rate. Okay, so for example, I can transmit, for example, 3 packets, any numbers, 3 per second, for example, but here I receive five packets per second. So I receive more than what I can process the data, more than my resources. Because almost network, you have to think about resources, computational resources, storage resources, and so on. Okay. So if I receive data more than my resources, in this case, what I can do, I told you last time, I have a buffer, I have a memory, I have a buffer. So I'm gonna store the data. If hopefully, I hope this situation does not continue for long, right? I hope this doesn't stay for long. The arrival rate is bigger than the transmission. I hope this doesn't continue for long time. If it continues for a long time, I'm gonna store these packets in the buffer. Once the buffer is full, I'm gonna drop them. So you transmit something, I'm gonna drop it, right? Because I promised, but I was not able to do that because I got a lot of transmission. Okay, because the way the internet is designed, there is no coordination in the transmission. We have a lot of computers. We have too many computers, So you don't need to ask for a permission before you transmit. No coordination, right? If you want to transmit, just transmit. Even if the network is busy, yes, just transmit it. If I can deliver it, I will do it. If I can't, I cannot do it. Okay? So it's completely different from circuit switching. So I don't give you anything, okay? That is why, okay? Okay, so circuit switching is good in case of voice, okay? Because I give you resources. So you already guarantee certain resources. That's why the quality of the voice is much better than the quality of the voice is here. Here, sometimes it's okay, but sometimes it is not, okay? No guarantee, okay? Depends on the situation in the network itself, okay? But here, all the time, because I give you resources, it's allocated for you, okay? So what I want to say, because sometimes some students think, yeah, circuit switching is bad all the time. No, it is designed for voice, okay? For voice, I'm gonna keep all the time. So we're gonna keep, so I'm gonna transmit data all the time if it is voice, right? But if you use it for data, it's gonna be too bad for data. Why? Because for data, if this is your computer, if this is a computer, okay, and this is another computer, okay, if I'm not gonna transmit data all the time, no one is transmitting data all the time, right? So sometimes this is your activity. So for example, I'm not transmitting anything. Now I'm reading my email, okay? So now I'm making some or receiving some data, okay? Sometimes nothing, okay? Sometimes I'm watching a video or so on and off this way, right? So the problem here is if in case of circuit switching, I'm allocating to you, resources. The problem, if I allocate resources to you, okay, this is the main point. The main point is that if I give you resources and you don't use them, and you don't allow anyone else to use it, we lose the resources. You get what I'm saying? This is the main point. So if I give you resources, you don't use it, you don't allow anybody else to use it. So both of us lost it, right? This is not in the packet switching. In packet switching, okay, you can share. Okay. That means if you that means if you don't send data, okay, I can use some other data because I'm not gonna allocate anything for you. Got what I'm saying? Anyway, so here to clarify more what I explained here, I want to explain what I mean by multiplexing and demultiplexing. Okay. So let's see what I mean by multiplexing. I'm going to tell you what is the idea. Very simple. If you have a cable, and this cable can carry, for example, 100 gigabit per second, right? So for sure, I cannot give this cable. There's too much data. I cannot give it to one computer. Is that right? So what happens? I'm gonna get data from many computers, okay, and then I'm gonna merge them and then transmit it through only one wire. Is that okay? So that's what we call multiplexing. Okay. Also, we can use other. Here is the opposite. Demultiplexing. Okay. So here, once I receive the data, I'm gonna transmit this one. Again, the main reason is that here this cable may carry a lot of data. So multiplexing combine data from several input lines and transmit over a single medium. Demultiplexer actually separate or demultiplexes the multiplexed data and delivers data to the output here. Okay. Yeah. So the idea is used mainly for efficient use of high-speed links. This is the main idea. Anyway, to do. Okay, so Anyway, so here what I want to say. So here you are using static. It's like static multiplexing. تمام. Okay. Okay. In circuit switching. Okay. So if I want to do so that's what so it's like static switching. Static again means you have resources. If you don't use it, no one is going to use it. That's yours. What I'm saying. So to do it, we can do it in two different ways. We can do something like frequency division multiplexing, or I can do time division multiplexing. So every color here, we have, I assume we have 4 users, okay? Every color here is for 1 user, okay? Here I'm explaining, I have a certain resources, okay? What we do in circuit switching or static multiplexing, what we are doing, I give you resources. You have a certain resources, okay? So how I give you resources? Again, resources means bandwidth, certain bandwidth, okay? So you can divide either the frequency or the time, okay? So here, this is the whole bandwidth. This is the whole bandwidth, right? So you can transmit all the time. So again, every color here is 1 user, so you can transmit all the time. But you can transmit a small amount of data because I give you small bandwidth, okay? But it is used all the time. So okay, so this is one way to do it using by dividing the frequency. The other one you can divide the time. Okay, so as you see here, you have the whole frequency, you have the whole bandwidth, the whole, okay? But you are gonna have time. So here you have this time, and then you should not transmit. Someone else is going to take it, okay, and so on as you see. Again, so this is 2 different ways to do the static multiplexing. But again, what is bad here? What is bad here? Again, if you don't use your allocated resources, no one else is going to use it. So we lost it, okay? And this is very bad in case of data communication, because in data communication, you don't need to transmit all the time. It's different from voice, right? In case of voice, we're talking, right? So once we start a call, we're gonna talk, okay? So it's completely different, okay? So anyway. So here I'm explaining multiplexing. So for example, here, this is the time we have 3 user, A1. So here I'm going to take one part from you, one part from here, one part from here. I can put them together this way, okay? So to do like multiplexing, okay? Okay. So what is the disadvantage of static multiplexing? That's exactly what I mentioned, okay? The idea, okay, look at this scenario here. We have four users, 4 people, okay? However, this one is using the channel or just using his or her resources. This guy, I give allocated resources, but he's not using it. You got what I'm saying? And I cannot give it to someone else. This is a problem. You got what I'm saying? So that's why when I do multiplexing, you can see here sometimes here I'm not using the channel. This is the resources. You didn't use it, and you didn't allow others to use it. That's why it's not good here. Okay? So again, the conclusion, again, I'm not saying this is bad. This is bad in case. It's good in case. It is bad in case of data communication, right? It is good if you transmit all the time. So actually, yeah, it's okay. Transmit all the time. I give you resources, you use it, that's it. So anyway, I have no sharing. So here a summary. In case of circuit switching, it's end-to-end dedicated resources. Okay. Here, this is the main thing. The performance is guaranteed, right? Because data is not delayed at switches or because you have a link. You have guaranteed resources. That's why performance is guaranteed. However, if you use the internet, performance is not guaranteed because you don't have allocated resources. Okay. Maybe you start phone call, okay, using the internet, and the routers are busy, so you cannot continue. The performance is going to be too bad, right? And sometimes it happens. I'm not sure. Sometimes, okay, it happens. Sometimes when you call someone over the internet, sometimes you feel you have a bad performance, right? this should not happen in case of circuit switching because you have your own resources, right? Anyway. So for voice traffic, a high percentage of utilization, because most of the time one party or the other is talking. So that's okay, that's good. However, in case of data, most of the time the channel is idle, okay? Some delay to establish, maybe this is also another problem. We need some delay in the beginning to establish a connection. Why? Because to establish a connection, because before you talk, you need to establish a connection, right? So here, maybe there is some delay in the beginning, okay? After that, after you establish a connection, you have a fixed data rate, okay? With no delay other than just a propagation delay, okay? Because as I explained last time, in case of packet switching, there are other delays, as I explained last time. When you transmit a packet, it has to go to a router. If the router is not free, it's busy, so it's going to put it in the buffer. You have to wait for your turn, and then you have to make a processing to the packet before you decide where it has to go and so on. So it's not completely different from switching. Okay. Packet switching, this is what is used in the internet. So messages here are divided into smaller size packets. Okay, I'm going to tell you why. So here what happens in the internet, okay, if I want to transmit a message, a big message, right? What I mean by message, it can be a file, 7 megabytes file and so on. That's a file, okay, or 10 megabyte file, okay? So what happens is that in the internet, it's not a good idea to send big messages, okay? So what we do, we cut it into pieces, okay? We call them packets, small packet. So if you have a very big file, okay? For example, 10 megabyte, for example. So this file, we cut it into pieces, okay? And we transmit these pieces, okay? And for sure, in order to enable the receiver to reconstruct the file again, we have to number. We should number them. Yes, we do that. We number them, right? Because there are several things can happen. Maybe some of them is going to take different routes. Okay, so maybe number 5 is going to be delivered before number 2. You got what I'm saying? This one thing can happen because they may take different routes. Okay, another thing can happen that maybe number 3 is dropped, missing, right? So that's why we need to order them so that the receiver, if the receiver misses any one of them, is going to ask the sender to send it again. You know what I'm saying? And reconstruct it. Yes. But the question now is why you need to divide into small pieces? Why you just transmit the big one? Just gives the big one to the internet. Okay. I'm going to tell you the one time I asked this question to a student. One student gave me a very good answer, very short and very good answer, very short. He told me, and this is correct. Okay. He told me we have to divide the message into smaller messages because smaller messages are going to be nicer, are going to be better for sharing because we share the resources. This is a key point. You got what I'm saying? If you send something too big and you send it to the router, you are going to get too much time from the router. So this is going to affect other people. Okay? So smaller are better for sharing because we share the resources. You got what I'm saying? Because we share the resources, it's better if we can, if you send small data, and that's exactly what happens. Okay, so here, and that's good and bad. I'm going to tell you why also it is bad, but anyway, it's bad because the overhead. What you mean by the overhead? Every packet here, remember, every packet has two parts, by the way. So it has what we call the payload. So it has header and the payload. The payload is this piece. So I'm going to take this piece, I'm going to put it here as a payload, okay? And then I have a header. This header is overhead. You got what I'm saying? What I mean, if I want to transmit 10 megabit per second, I have to transmit more than 10 megabit per second because I have to do some overhead here, okay? So this header should have information about who is the sender, who is the receiver, some information about the order and other things. You got to say. So this is the bad thing is that we need to put overhead. Okay. But again, this is much better, as you will see later, for sharing, much better. Okay. And that's how we do it in the internet. Okay. So each packet contains control information in the header, as I explained. Something like the source, the destination, sequence number, and so on. Okay. And also some information to check if there is error or not. Okay. Anyway, number two, packets traverse the network individually and may use different routes. That's what I told you. So packets can take different routes, and that's why we need to reassembly and reorder them at the destination. Okay, that's why you should have numbers here. Okay, packet switching. Here we use here. So instead of I think we used here static multiplexing. That's what we used here in case of circuit switching. Now we are using what we call statistical multiplexing. So let's see what multiplexing means. It's very easy. So bandwidth is used on demand when needed, as needed. You got what I'm saying? In other words, I'm not gonna allocate anything to you, right? But resources can be shared. Okay, no resource reservation. Packets share the network resources, so we share the buffers, we share the switches, we share. Okay, each packet uses full link bandwidth. Packets may be buffer, as I said, when it is busy. So that's why we call it store and forward. So routers and switches are store and forward. Store because if the router is busy, okay, so I'm going to store it in the buffer, and then it has to wait for its turn. Okay. Aggregated input traffic can exceed the link capacity. Buffer may overflow, so I'm going to put in the buffer. The buffer can overflow, congestion can happen at the routers. Okay. Protocols are needed for reliable data transfer. Yeah, because look here, this is how it is. You can transmit a packet and the packet can be dropped, right? It's out of my hand, right? That's why if you care about reliability, as I said last time, you have to implement a protocol to correct something like that if it happens, right? That's why we have, yes, that's why we have some reliable data transfer. We have some mechanisms, okay, to use that. Error control, congestion control, and so on. Okay. Maybe I want to explain here. Maybe this is a very good figure to understand what I mean by statistical multiplexing. Okay. So as you see here, guys, this link is 6 megabits per second. Is that okay? So here, again, I'm not gonna allocate. The easy way, or circuit switching, I can allocate. I can tell to this guy, you have 3 and you have 3. That's it. And by this way, all the time, nothing will be dropped all the time because you have your own resources. You should not exceed 3, and this guy should not exceed 3. So always we're not gonna exceed the 6 all the time. Is that okay? But for sure, this is bad because if you don't use your resources, you're not gonna allow the other one to use it. This is what I said, right? However, you can transmit with higher rate, okay? But hopefully this situation does not continue. So for example, as you see here, guys, this is the bandwidth usage here. So sometimes you are up, but the other guy is down, okay? So sometimes you use up to 4, okay? But at the same, for sure, if you look here, guys, if 4 and 4 is 8, it's more than this one. More than this one, okay? But hopefully, it should, both of them, this is the point. I hope both of them are not gonna transmit 4 megabits per second at the same time for a long time, okay? And that's what happens. So for example, if this is how your transmission look like, this is how the other one transmission look like. If I add them together, This is the result if I add them together, and this is the limit. The limit is 6. Okay, because this one is 6 here. Okay, so anything above the 6 here, so I'm gonna buffer them. I'm gonna buffer them. And if this continue, so here what happened here, because the summation is more than 6, I hope this doesn't happen a lot, because if this happen a lot, I'm gonna start to drop the packets. Okay, so again, that's why we call it statistical. Statistical means, I think if you work on communication, you will understand this better. In communication, we always care about statistics, about percentage. Okay, so the communication 90% of the time it's okay. Okay, I'm happy. Okay, so maybe in some other application 1% is too bad. Right? For example, intrusion detection, someone is going to attack the network. So one time, if you make a mistake one time, it's already the damage happened, right? It's maybe different way of thinking on this with the communication. Okay, so communication, we look at the statistics as long as the communication is fine, 90% or 95% of the time, that's okay. If 5% of the time there is no communication, it's not a big deal. I want to tell you something here, guys. It's just related to what I explained here. Actually, what I did here, something somehow related. Okay, look here. If you have a cellular network, okay, the cellular network cannot, for example, serve in a certain area. So you have here a tower in a certain area. Okay, this is a cellular network. This cellular network, for example, it has resources for 200 users. So in this area, so I cannot serve more than 200 users. Okay, if 200 users make a phone call at the same time, I can serve all of them. Is that okay? What happens actually, I give resources. Here I allow. Here I can have contract with more than 200 users. Okay, so for example here. I can have here up to, for example, just in numbers, just to understand the idea. I can have up to 400 users. Okay, why? Simply because not everybody is gonna talk at the same time all the time. You know what I'm saying? So hopefully, it's not gonna happen too much that 200 people talk at the same time. You know what I'm saying? If it happens that this happens. So if you try to call, you're not gonna call, right? It happens in some countries. For example, I'm from Egypt. For example, it can happen. For example, if we have like a celebration, holiday, something like that, all the people are talking. Okay. At this time, when you try to call someone, okay, so you will not be able to call. Also, it happens if there's like something like disaster, natural disaster. The people are calling their friends to see if they are okay or not. So there are out of phone calls. In this time, if you call, you cannot call because again, it's the same idea, right? Because if think about it, if I'm not going to work on the worst scenario, the worst case. I'm not going to work on the worst case. You kind of say the worst case is 200 people, right? It's going to call at the same time, but this is very rarely. I'm not gonna make investment and money, right? So that to guarantee that 1% of the time it may happen that 200 people talk at the same time, I'm not gonna do that, right? Also they do that, okay, in the power systems. In the power system, okay, because maybe the story is somehow different from here, okay? In power system, if you look at the consumption of the people power consumption, so this is the consumption of the people, something like that. So it's around peak hour, 2 or 3 hours, okay? From 4 o'clock to 8 o'clock, most of the people go home, most of the people start cooking. So the consumption, just for 3-4 hours, the consumption is too high. You know what I'm saying? So I should invest money and I should have a generation capability to cover these 2 hours or 3 hours. Because I'm saying, yes, it's not the best thing. In some countries, good countries, okay, they don't do that. That's why they turn the power off. Once you exceed, for example, if this is your limit, once you exceed, so they turn the power off from some places, they do that. However, what happens, because electricity is something very important, I have to make sure it's available all the time. So that's why, yes, we invest too much money just for 2-3 hours. Yeah, because the consequences, if you don't do that, yes, you can save time, but if you disconnect the power from people for 2-3 hours, it's not acceptable, right? It's somehow different in communication, right? So in communication, even if they cannot communicate 1% of the time, 2%, it's not a big deal, usually. So here, yeah, if source peak rate can exceed link rate, packets may not be queued. Also, if buffer capacity, yeah, is not sufficient, packets may be dropped. Okay. Yeah. So I have a very good numbers here, just I think this number can explain the numbers I have here. Can explain exactly what I want, what I explained right now, but in numbers. Usually, we can understand things better from numbers. So let's look at these numbers here. We assume we have here one megabit per second link, okay, and we assume we have n users, okay, and each user is active only 10% of the time, because this is data communication. Data communication, your computer is not gonna transmit all the time. You connect to the internet, but you're not using it, right? So I'm not gonna use it all the time, right? So here we assume you are going to use it only 10% of the time, okay? And by this way, if I use circuit switching, I can only serve 10 users. Why? Because I'm going to divide 1 megabit per second. I'm going to divide it by sorry, I think something is missing here. Yeah, I'm saying if I have 10 users, yeah, the other way. If I have 10 users, okay, that means I can, everyone is going to get 100 kilobit per second. Is that okay? However, yeah, here I think we're going to assume, yeah, it's the other way. So we're going to assume if every user needs 100 kilobit per second, in this way, in case of circuit switching, I'm gonna divide 1 megabit per second divided by 100 kilobit per second, and this can give you 10. So I can serve 10 users. Okay. The problem is that these users, they are not going to use it, as I said before. Okay. Now, I just want to. Numbers are very interesting here. Okay. So here, 10 users. Okay. But if I allow 35 users, which more than 3 times, 35 users use it. 35 users, okay, and they are active 10% of the time, okay, the probability that more than 10 are active, which is a problem for us, is at the same time is less than this number, almost close to 0, okay. You got what I'm saying? 35. So if I give it to 35 users and everyone is active only 10% of the time, the probability is that you have 10 active, okay. 10 means you already use the whole thing here, okay. Anyway, so it's only very small probability, okay. Anyway, also, yeah, here also this is a very good figure to understand also the difference between static multiplexing and statistical multiplexing, okay. In case of static multiplexing, as I told you, you have dedicated resources. That's why you look here. This not using, also this not using. That's why you can see gaps here. For sure, we lose that, okay? I can, here, these 2 users are not using it, but and also I didn't give it to someone else. That's why they are empty here. But here, look what's gonna happen here. So even if you don't use them here, I can get data from, from others. So always I occupy, or I fully utilize the channel here. And this is the main thing. I can always utilize it because I can get data from others, okay? Anyway, so we're gonna continue next time. Okay, 6 o'clock. So as I told you guys, next time we're gonna start 5:40 because I told you I have a lecture, I have to download the file. It takes 20 minutes to download the file, okay? So 5:40, okay? and we're gonna finish 6 o'clock. Sorry, 4:50, and we're gonna finish instead of 5:50.